All right, August 5, 2016. This is continuing on the LED faucet light hacking. So I've got one LED faucet light that I completely tore down to expose the circuit board. And it's got the LED in the middle, 3 colors, 8-pin microcontroller, and it looks like a capacitor. First I thought 2 capacitors, but this next one that I have here in the vise, I've took a different approach where I basically cut it right at the top of the circuit board so that I'd be able to access all of the pads on the board. And then I realized an even easier way would have been just to push it against like a belt sander, carefully sand it down. But I did get to the point where I can read the silk screen on the board. So the bottom of the board has some silk screen, which I have not bothered to Google. So there may be a schematic. You can see the 4 RGB LED pins. And I suppose if you're ambitious, you could reverse engineer this since you can see the traces on the back. And now with this, you could deduce the traces on the front. But the part that was important was I can see the through holes for the thermistor, which are clear, and then the only other holes that go to the bottom of the board are over here in this corner, which are on the top of the board are these two. So I put soldered leads onto those two, assuming that these must be the 2 pieces of looks like 30 gauge magnet wire that comes out of this generator to come onto the board. And then reading the silk screen, this is C1 and L1, and they're relatively large compared to the other component, which implies some kind of a power converter. So I took the turbine off. That's what the turbine looks like. Turbine off the shaft, and hooked into this little mini drill driver that I can turn on while it's in the vise, so I can probe around while it's spinning. And this is turning at low speed. And what I've found is that if we turn it on, so we're getting at that speed, which is very slow compared to design speed, about 200 millivolts AC. So we're getting AC out of it, and then it appears that the AC is going through some sort of a power converter to power the LEDs in the microcontroller. And I'm guessing that because it has an inductor and a capacitor on there. And some of these other components I've kind of scratched a little bit too much. You can see the silk screen in the center says RGB. There's resistors. I don't see anything. It's labeled with a D for diode. But in any case, I'm assuming that you'll get a couple volts AC out of this by spinning it at the design speed like you'd get with a turbine on there, and that these are the power leads over in this corner. So it looks like, tentatively at least, that the easy way, let's see if I can get this out of here. The easy way to get access to the raw output is going to be just to grind this thing down on a sander carefully till you expose the pads and you can pick off on it. And then if you're going to do a bunch of them, you could just make a jig so that it just sanded down to a common level, and you could get access to these 2 pins. And then you have to build some kind of a low voltage high efficiency rectifier to get your DC voltage, and you'll be off and running. I haven't measured the current out of it or measured it at speed, but then the disadvantage is, let's compare this with my third one. Is that the side that I've removed, is the side where the water flows around it. So this is where you could repot this and bring these wires out to the side, and maybe I'll get ambitious and do that. Put this back together, although I've clipped off the alignment bosses that are in this thing. You can look at this from the back. I clipped off those four little protuberances. See if we can get this out. Almost there. There we go. So that's how much was ground off, and that would be the easy way to do it. Just basically just to braid away everything till you get down to the board, and then or you could just clamp this in a vise and just mill the top of that right off, right at the top copper, like I did with the hacksaw in this case, to expose the board, and then you'd be there. But it's an AC device, and I suppose I should take my first one and crack into the motor and look at that, or the generator. So it's an alternator, I guess. So it probably has a permanent magnet on the spindle and some windings. It looks like maybe 4. You probably may not be able to see this on the camera. I can barely see copper color, no copper, and copper. So it looks like there might be four phases that the magnet goes by to make the AC that comes out of it, and then they're rectifying it to run the system. So anyway, this is the next stage. This is how you get to the power. It's over here in the corner opposite. Let's get this oriented here. These two pins, these two pads on the PCB are right over here. This is where power comes from the alternator into the PCB. And so if you're able to grind very carefully just that corner off, you could probably keep it functioning and pick off the power that way as well, if you had a reason to do that. But the entire thing would have to be resealed in any case to put it back into the Faucet application. It's April 5, 2017.